levels or tire pressures is the checking and adjusting of your air brakes. While lack of oil or low tires may result in component damage, lack of brake adjustment can result in loss of life. This presentation is designed to assist the professional driver to not only determine when a brake adjustment is required, but also the method used to adjust the brakes correctly. This slide illustrates a typical Type 30 brake chamber. Its total stroke from fully released position to its fully applied position is 2.5 inches. Notice at 2.5 inches, the chamber push plate, visible here through a hole cut in the chamber housing, has fully bottomed out. The need for adjustment is determined by measuring the push rod position with the brakes fully released, and then pulling or prying the slack adjuster and push rod to determine the amount of free play or slack. If push rod travel is 1 inch or more, the brakes must be adjusted. This could be the most important inch of your life. Most slack adjusters are now equipped with a spring-loaded lock that prevents the adjusting bolt from backing off because of road vibration. This locking sleeve must be depressed and held in while the adjusting bolt is being turned. Tighten the adjusting bolt until solid resistance is met. This indicates that the linings are touching the drum. Then back off the adjusting bolt between 1/4 and 1/2 turn to restore proper running clearance. It's important that you know that some adjusting bolts require a normal clockwise turn to set up the brakes, but some require a counterclockwise turn. If possible, try to observe the direction that the camshaft is turning while the adjustment is being made. The cam should rotate in the same direction that it would if the brakes were being applied. This is illustrated by the arrow on the cam end on this slide. Most importantly, be alert for any outward movement of the chamber push rod and slack adjuster arm while the adjustment bolt is being turned. This movement means you're turning in the wrong direction. Recheck the slack measurement by pulling or prying the slack adjuster as before. A properly adjusted brake should have 1/2 inch of slack. Before proceeding to the next brake, be sure that the locking sleeve has returned to its normal position. Incidentally, if you were to make an 80-pound air application at this time, you would find that the chamber actually stroked 1.5 inches because of stretching and compression of the various components. This reverse view of a brake assembly shows the action of the S-cam in exerting an outward push on the brake shoes. This close-up view shows more detail of the S-cam, rollers, and brake shoes. After the first 10 miles of running after a brake adjustment, it's wise to stop and make a hand check of the brake drum temperatures. A hot drum could indicate a brake that has been adjusted too tightly. Now let's see what happens to a marginally adjusted brake when driving in hilly country. Here's a brake that has 1 inch of chamber stroke when the slack adjuster is pulled or pried. With an 80-pound air application, this chamber would stroke 1 3/4 inches. This leaves 3/4 of an inch of chamber stroke in reserve. A cast iron brake drum will expand when it's heated. This expansion can cause the brake chamber to stroke a further 1/2 inch, reducing the reserved stroke to 1/4 of an inch. Notice the chamber push plate has almost bottomed out. At high temperatures, brake lining wears extremely rapidly. Each 10,000th of an inch of lining wear causes the chamber to stroke a further 1/4 of an inch. 1/10,000th of an inch is approximately the thickness of 3 sheets of paper. The accumulated effect of poorly adjusted brakes, heat expansion of the drums and lining wear can cause a total loss of air chamber reserved stroke, which results in total loss of braking. This will result in a runaway with potentially disastrous results. This measurement indeed could take you within an inch of your life.